Okay, really quick. Just wanted to show you just on kind of a little demo thing that I did. So I took the strain gauge sensor. Um, what I did is I attached it to so the strain gauge is on the connector. You saw that process before. The board is hot glued to the shaft of this thing. And one thing I wasn't really thinking of is when you normally do a socket wrench extension, this whole thing is free moving. So if this approach where everything's attached to the socket wrench extension, really everything has to be on there, or as you're cranking the thing, the wires are going to get twisted, so that's fine, but pretty much there's not really a way around it, right? If this is attached to the shaft, everything's going to be rotating as you do the socket wrench, so everything has to be on the wrench, or it's going to get twisted a little bit, so it still will work in theory. But so I've got this thing on here. I want to show you kind of the way mine works. So this is just connected to, so I don't have a screen on mine because I think you all use them all up. There's none left right now. But I kind of have mine sort of working without it. So if I unplug it and plug it back in, trying to do this, I kind of need three hands to do this. So when I plug it back in, so the first thing mine does is it shows red. It's going through a calibration process right at first. So it's calibrating red. When it turns green, that means it's done calibrating. It's calibrating for a while. And again, while it's calibrating, it's kind of just keep reading strain gauge values and kind of averages them together. I'll show you the code for this thing, but I just kind of want to show you the way mine works for right now. I need to add more features. So if you turn the torque up and down right now, it doesn't really show you, but it blinks the little red light when you turn it up and down. So up and down. Let's turn it down so that we actually get a response out of this thing. I'll turn it down kind of as far as it'll go. Mine is set to do 5 pound-feet per time you push the button. It stops at a minimum of 10. So once it gets down there, so it should be about 10 pound-feet of torque. Let me try to wedge this between my knees and do this. So if you torque it, sorry, wedge this between I really need three hands. So when I torque it, see how it blinks red to say the torque got exceeded? Okay, and if I increase the torque, I can increase the torque to the point where I can't turn this with my hand. That's all my strength, and I can't torque that by hand. So turn it down. Yeah, there I can do it still. Okay. I can get in that direction. Okay, yeah, so I'll show you the code for this for what I've got right now as an example, but just kind of a sort of basic functionality. So the noise that I get on this, it drifts. The values that I read, it drifts 200 to 1,000. My code is set to, it's sort of constantly averaging the value that it reads off this thing, so it's sort of constantly, even if it drifts, it's kind of correcting itself. But the readings I get for hand twisting this, the magnitude for sort of full hand force is about 20,000. I can get a reading of plus or minus 20,000. The noise is around 1,000 or 200 to 1,000. The drift is around 1,000. So the signal is big enough. It's bigger than what I apply with my hand. Yeah, so just kind of wanted to give you a little just initial sort of idea of the way that I have this. It's really important that you not have strain. So if you apply strain to these wires, so applying strain to the wires can really mess it up. I'll see if I get it to trigger if I'm just doing, yeah. So you're just pushing on the wires, tugs on that strain gauge. So you really want to make sure that while you're using this, those wires are either really flimsy going to the strain gauge, or the wires don't, you don't want the wires to be able to be bumped or squished, because they can, just the strain from the wire can trigger the strain gauge, you can see. So anyway, some thoughts to keep in mind. I just want to show you my example.